Hello, this lesson covers 5.4 and 5.5, which I have named Finding Zeros by Dividing Polynomials. For the warm-up question, let's try to sketch a graph of the polynomial. We've got a bunch of information, so I'll go ahead and draw my axis, and it looks like I've got a power of 5, so that's useful. I have a y-intercept of -9. I have an intercept at 3. I have an intercept at 1, and I have an intercept of -1. This, as x goes to negative infinity, y goes up, so that's this way, and then this one is down. So I'm gonna have this and this. Okay. So now I need to pay attention to my multiplicities. So these both have multiplicities. So I'm just going to highlight them because I'm going to forget as soon as I start drawing this curve. Um, Now, if I'm drawing the curve, let me just go ahead and start connecting things. Multiplicity, multiplicity. So I believe this is what the function would look like. Now, without using a calculator, go ahead and do this division. It's probably been a very long time since you've done long division, but let's jump right in. So 21 can go to 28 once. So that's going to be 1 times 21, and subtracting that gets us the 7. Bring down the 9. I believe that goes in 3 times, which gets us 63. Again, subtracting gets us 16, so we end up with a remainder. Now, the reason we do this is just as a reminder that we can also divide. Sometimes we divide polynomials, which is what we're going to be covering today. So we're going to use synthetic division to divide these polynomials. Synthetic division has a little box and then a longer rectangular box. Inside this little box is let's say, the solution if we solve the denominator. Denominator is solved. And in this box, we have the coefficients of the numerator. Okay. I'm actually going to make this a little bit smaller and move it out of the way. Okay. That way I actually have room for my actual problem that I'm going to do. So here would be -1, because if we set this equal to 0 and we solve, we get -1. And in here we get 5, 3, and -2, which are your coefficients. Okay, the sign goes with it. So the first step is to bring down the first term. From there, you're going to multiply the number at the bottom times the little box and put that in the next column. You're going to do that math, and it's going to be -2. You're going to repeat that process, and you're going to solve. Now, ultimately, the goal is we want this to be 0. That's what we want, right? If it's not 0, we'll talk about what happens. So what you end up with now is 5x minus 2. Because we divided out an x from x squared, we now have just an x, right? We've divided out a power. We used to also teach long division, and we've kind of moved away from it because it's just not that important for upcoming classes. But there are specific reasons when you use synthetic versus long division. So, synthetic can be used when the divisor has a coefficient of 1. So, for example, if it was divided by x minus 3 or x plus 5 or something like that. That is the only time you can use synthetic division. Long division has to be used if there is a coefficient that's not a 1, for example, like 2x minus 3 or 4x plus 1, right? If there is a number in front of the x, you have to use the long division, which again, we no longer cover, so you don't have to worry about problems like that. Now, the purpose of using synthetic division is to actually get the polynomial down in a power so that you can hopefully factor it the rest of the way. So in this case, let's see if we can get something factorable. We have 6, 11, negative 31, and 15. So we'll bring down the 6 and multiply. Now we have 23. We'll multiply. We'll add that together. That's 15. Right? Yes. I'm doing this live time, so I don't have my answers in front of me. And then we get 30. So now we have 45. This is your remainder. Also, let me just double check my math. 6 times 2 is 12, 23, 46, 1, 5. Yes, okay, cool. So we end up with a remainder. That means, I told you I would let you know if it wasn't 0. A remainder means that the divisor is not a factor. Two is not a factor. Okay, there's nothing else we can do here. We can't find remaining x-intercepts because 2 is not an intercept. It's not an x-intercept. So we're kind of stuck. We can't move on. Let's try this one instead. In the little box, we have 2. In the long rectangle, we have 2, negative 1, negative 15, and 18. Bring down the 2 and multiply. Add, multiply again. Multiply again. Oh, good. We got 0. So that means, switch colors here, 2 is a factor. That also means what we're left with is 2x squared plus 3x minus 9. This ideally is factorable. I say ideally because I'm doing this and winging it, so I'm hoping this is factorable. So that means we want to multiply to negative 18 and add to 3. Yes, this is factorable. I remember this now. So factors of 18, I immediately see what's going to work for me. It's going to be 6 and 3, where the 3 is going to be negative. So I can factor by grouping. So let's go over here and write this out. 2x squared plus 6x minus 3x minus 9. So we can factor out a 2x and we're left with x plus 3. We can factor out a negative 3 and we're left with x plus 3. And now we have 2x minus 3, x plus 3. And don't forget, we also had the x minus 2 from the very beginning. So this would be what we would call your factored form. Now, if you want the x-intercepts, go ahead and set everything equal to 0 and you get 2, 3 halves, and negative 3. Let me shift all this over just a little bit. There we go. Let's do it again with this power of 4. We have negative 1. In the box, 1, 3, negative 6, negative 24, negative 16. Bring down the 1 and multiply. Multiply. Multiply again. Multiply again. We get 0. Awesome. That means we have x cubed plus 2x squared minus 8x minus 16, which is again factorable by grouping. Factor out the x squared and you have x plus 2. Factor out the negative 8 and you get x plus 2. So now we have x squared minus 8, x plus 2, and again, I'll do it in red. Don't forget the x plus 1 from the beginning. There's your factored form. Now, if you're solving for x, we have x equals -1, x equals, let's see, 2 root 2, plus or minus, and we have -2. I'm going to come over to the side and very quickly talk about the square root of 8 in case you're not quite sure how to find that. If you bring that 8 over and you take the square root of 8, you know that 4 times 2 will equal 8. And the square root of 4 is 2, leaving the other 2 inside. And there are always going to be two solutions to a root, which is where the plus minus comes in. It also tracks, since this is a power 4, it can have up to 4 x-intercepts, so it makes sense that we have 4 answers. Moving on. How is the range of a polynomial function related to the degree of the polynomial? So this really brings you back to thinking about your even versus your odd functions, right? Remember that even functions look something like this and can have more hills and valleys, but odd functions will always have opposite ending directions. So in even functions, will have a max or min, depending on the direction, depending on direction. But odd functions always have a range of -infinity to infinity, no matter what. They're always going to go up and down forever. Is it possible for a graph for a polynomial to have no y-intercepts? No. X-intercepts? Yes. Again, that comes back to these even functions. If you graph an even function and it happens to be fully above the axis or fully below the axis, you never end up touching the x-axis. That's possible. Y-intercepts are different. They're always going to touch the y-axis, so there's no avoiding that. Finally, in synthetic division, y is the quotient 1 less than the dividend. As discussed earlier, when you are dividing out an x, you're essentially subtracting the powers. So if this was a power of 4 over x, we would end up with x cubed. Those powers are subtracting. Okay, that's why. All right, now that we've talked about some of the conceptual stuff, let's go back and solve more of these. And then we're going to find the remaining factors. So we have 4 in the little box and -3, 6, and 24. Let's bring down the -3 and multiply. Whoops. -6 multiply -24, 0. So we have -3x minus 6 equals 0. -3x equals 6, and x equals -2. Okay, so -3x minus 6 times x minus 4 is factored form, and the x's will equal 4 and -2. Let's do the next one. -2 in the little box, 2, 1, -5, 2 in the long rectangle. Bring down the first term and multiply, and repeat that process all the way. So now we have 2x squared minus 3x plus 1. That is a quadratic. We want to multiply to 2 and add up to -3. So I'm thinking -2 and -1. So 2x squared minus 2x minus x plus 1. Factor out the 2x, factor out a -1, and we'll end up with 2x minus 1 times x minus 1. And again, don't forget the x plus 2 from the beginning. There's your factored form, and then here are your x-intercepts. Okay. We'll do it again one more time, but now we're also going to graph the polynomial below. Here we can factor by grouping, so I'll go ahead and factor out the x squared. Here I'll factor out a -4. So now I have x squared minus 4 times x plus 2. X squared minus 4 is actually x plus 2 times x minus 2. So what you'll notice is that we have two of these, which is going to be a multiplicity. So I'll go ahead and draw those over here. My y-intercept is -8. So this is a positive power of 3. So I know that my end behavior is going to look something like this. And it looks like this one right here has this multiplicity. So now I'll go ahead and draw the curve. So down, whoops, down, and then up. In the next one, I go ahead and tell you that x plus 1 is a factor. So we can go ahead and do synthetic division and find the others. So notice also that it goes from cubed to x. So it's going to be 1, 0, -7, -6. We want to account for the x squared term by putting in that 0. Bring down the 1, and then start your process. Okay, so now we have x squared minus x minus 6. Definitely factorable. I'm thinking -3 plus 2. So we're going to have 3 and -2 and -1. No multiplicities here. So -1, -2, 1, 2, 3. A y-intercept of -6. Also a power of 3, so there's my end behavior. And from there, we just follow it along. There it is, roughly. Okay, I believe these are our last two. We're going to repeat that process one more time, just get a little bit more practice. So again, I'm telling you x minus 1 is a factor, so we'll go ahead and put the 1 in there. 1, 2, -1, 4, -6. Bring down the 1 and multiply. Multiply, multiply, multiply. Now we have, let's see, x cubed plus 3x squared plus 2x plus 6. That looks factorable by grouping, if you ask me. Split that down the middle, factor out the squared, factor out the 2. You're going to end up with x squared plus 2 and x plus 3. Don't forget the x minus 1. So there's your factored form. If you want x-intercepts, they're going to be 1 plus or minus I root 2 and -3. It is okay to have imaginary numbers as solutions. Just keep in mind these are not graphable points, so it's a little harder to graph these. Okay, and that's why we're not graphing it. It's not going to be something you're expected to do. All right, last but not least, let's knock this out. So -2 is going to work for us, so we'll plug that in. 3, 5, 7, 15, and -6. Bring down the 3 and then get started. Okay. 5, I think I have made a mistake. Let me start over. This should factor. So 3, 5, 7, 15, -7. Bring down the 3, -6, -1. There it is. I knew something wasn't adding up. There we go. Now we have 3x cubed minus x squared plus 9x minus 3. Again, factorable by grouping. Take out that x squared and you'll have 3x minus 1. Take out the 3 and you'll have 3x minus 1 again. So we have x squared plus 3 times 3x minus 1. And don't forget x plus 2 from the very beginning. There's your factored form. And if you want your x-intercepts, they're going to be negative plus or minus I root 3, 1/3, and -2.